Let's start with the idea of a limit. The limit of f of x as x approaches a equals L means that f of x gets arbitrarily close to L as x gets close to a, and this has to hold from both the left side and the right side. There are also limit laws that make limits easier to work with. The limit of a sum, difference, product, or quotient of functions equals the sum, difference, product, or quotient of their individual limits, as long as, for a quotient, the limit of the denominator is not 0. Now let's use these ideas on a worked example. We want to find the limit as x approaches 2 of the quantity x squared minus 4 divided by x minus 2. Let's try direct substitution first, plugging x equals 2 straight in. On top we get 2 squared minus 4, which is 0, and on the bottom we get 2 minus 2, which is also 0, so we get 0 divided by 0, which is undefined. Since direct substitution failed, we factor the numerator instead. X squared minus 4 factors as the quantity x minus 2 times the quantity x plus 2. Now the expression is the quantity x minus 2 times the quantity x plus 2, all divided by x minus 2. The x minus 2 factor appears on both top and bottom, so we cancel it, leaving just x plus 2. Now substitute x equals 2 into this new simplified expression, 2 plus 2 equals 4. So the limit as x approaches 2 of the quantity x squared minus 4 divided by x minus 2 equals 4, even though the original function itself is undefined at x equals 2. Here's the trick to spot when you need this method. Whenever direct substitution gives you 0 over 0, that is a signal, not a dead end. It tells you there is a shared factor between the top and bottom that can be cancelled, usually by factoring first. Now for a common trip up. Learners often factor and cancel correctly, but then, out of habit, substitute x equals 2 back into the original uncancelled expression. That lands them right back on 0 over 0, and they wrongly conclude the limit does not exist. So here's the teaching tip to avoid that error. Once you cancel a factor, physically cross out that old line completely, so you are not tempted to use it again. Only ever substitute into the new, simplified line, and never look back at the original expression.